April 6th today. It's not April 4th. I made these on April 4th. Should have changed it over to April 6th. I'll actually do that in post. So when you guys have access to the slide deck, it should be your correct date. A couple of highlights. I'm going to go over, well, one little bit of information. The macro mods are on their way and being manufactured. Should get to hear about April 18th. I'm going to go over a whole bunch of information about the launch MVP. It's actually a lot longer of a section than I expected it to be. And I'll go over some revenue stream information. Specifically, one big bit of information, one new thing about the project is that I've been thinking about it more and more, looking at the different business models that are out there that currently work and seeing how we could basically infiltrate that area and what we could provide to the world. Specifically, before I move on any further, I do want to make this into its own business. I don't think it'll be my primary business. I think I'll still be working at my current company. I don't see anyone else trying to leave their companies to work for this business in particular. But I do want to make this a lot more serious and put a lot of effort into this. And there are a lot of ways that money can be made in this type of in this environment. So first off, let's go over like the main things, the main coding areas. Let's go to the features to demonstrate for MVP launch. Things that we're going to need. I kind of condensed them down even further from what I had before in previous presentations. But we need modular hardware abstractions. That's the big thing. That's pretty much why we exist. It is the reason why libembeddedhal exists, is to be an abstraction layer for hardware so that people don't have to worry about all the register manipulation, bit manipulation, that kind of thing. Testability. The code, a lot of development environments for embedded are not really built with testability in mind, outside of like actual, telling people just to test it on their actual hardware. There are some applications out there that allow you to do software simulations, but those are far and in between. They usually won't support your particular software. Highly configurable and multi-platform. It's another big selling point for libembeddedhal, is that you can write it somewhat once and then deploy in multiple different areas. If you design your code correctly or follow our guidelines on how to build multi-platform applications, you can very easily build a blinker program that can work on any and all hardware, as well as anything more sophisticated than that. Easy to install, either using Conan. I meant to put down VC package, but I don't think we'll have that for MVP. I think we'll have that later on. And then last two would be clean, modern, independent, and portable code, as well as safety critical code as well. I'll go into what those last two sections mean at the end, but that last one's going to be very important to getting us to. Everything here is really important, but the last one's going to be that last little nugget that we need in order to make libembeddedhal something that's not just useful for hobbyists or for people doing their own projects, but for a lot of different areas. So modular hardware abstraction interfaces. So these are the set of interfaces that I believe we should have by MVP. Specifically, for the GPIO area, output pin, input pin, interrupt pin. These are separate APIs. We've talked about this before and why we separated them into these things rather than having them all as one big old GPIO class. Next, we have the hardware communication area. So that's SPI, serial, I2C, and then optionally CAN. There are other things like I2S, USB, and a whole other varieties of things that we could have put here. But for now, I think these are like the cornerstone hardware interfaces, hardware communication protocols that everyone's going to expect that we need to have. If we don't have these, then what are we doing? Next up, we have, for the analog area, we have ADC, PWM, DAC. I know PWM is not exactly analog, but it's close enough. So I throw it into that particular area. This particular these particular three areas are things that most people will expect. I think DAC a little less so, but still having ADC, PWM, and DAC are really important to show that we can do basic things. On the right-hand side, we have things that maybe people wouldn't expect as much. We have a counter, hardware counter. We have a timer. The difference between these two is that counter simply just counts up monotonically over time, just continues to go 1, 2, 3, 4 up to a certain point. It can overflow. That's one thing about the counter that it can do. It's only 32 bits. That's still in development right now. I think I'm going to finalize that hopefully soon. If you see the little check boxes, that means they're pretty much done and there's nothing really to change. They're pretty much going to be locked down unless someone, before we hit MVP, says, hey, output pin needs to have this particular API because of X, Y, and Z reason, and we debate it and see if that works. but the the yellow circles represent that we're still unsure if this is the final API. I feel like counter and can are nearly done, so I might just add them into the whole set for MVP, just because they're pretty much there. But that would add quite a bit more work on our table, on our plates, and I don't know if I want to do that just yet. Timer is purely there to execute a particular function when a time has elapsed. And it could either be a one-shot, meaning that it runs once, or it can be continuous, meaning that it runs every so often in that interval. We have only two sensors that I want to support for MVP, which is temperature and accelerometer. There are a whole variety of things like compass, gyroscope, barometric, pressure sensor, that kind of thing. We could have added all those in, but I think just having two really basic ones to kind of prove out the idea of these modular interface primitives would be important. Also, these normally wouldn't just be peripherals. These would be something that's a little bit like an external device that you interact with. But I still want to treat these as just basic interfaces. So these will also be on the MVP board. Then finally, we have actuators. This actually came in last minute. I still need to write out some issues for this. So actually, our table is actually missing things related to these. But motor, which is basically something that can run continuously, either one direction or another direction, usually circular motion. Servo, which is a positional control, primarily. You may feel that servo can be continuous motion and motor can be also like positional. For our semantics, we're just going to choose those to be the two cases. And if you wanted to have a servo that can act both continuously and positionally, you should implement both interfaces for that particular driver. That's kind of the way you settle that. And then lastly, we have rotary encoder, which doesn't have to be a quadrature encoder. It could be any sort of rotary position encoder of some sort. So that could even be a potentiometer. So these are the interfaces that we should have for our minimum viable product when we go out to launch. Another area that I was trying to find a good name for, finally came up with a good name, soft drivers. I've been talking about this for a while, but I don't know if I really kind of said it out directly. But basically, soft drivers are using devices or interfaces to make different other devices / interfaces. Only two of these have checkboxes for things that I actually want our code to support. Everything else is really kind of cool things that you could do. Actually, technically, the top one would be another one that we're going to actually support. But everything else here are things that I'd like to support in the future, but we don't have to support them anytime soon because they're kind of interesting. For example, the first one is using ADC and having some type of linear temperature metric to create a temperature sensor. You don't need to actually have looked at any of the data inside of a data sheet. Well, someone had to have at some point, but a linear temperature sensor, which has a linear voltage relative to its actual temperature, as long as you know what the 2 points from whatever the minimum voltage is to whatever that temperature is to whatever its maximum voltage is to whatever that temperature is at that point, you can draw a line and you can basically do a little bit of algebra in order to figure out what the temperature is. There's no need to look at any particular data sheet to write a driver for that. Now, whoever needs to use this particular class will need to come up with what those 2 points are, but after those 2 points are made, the rest should just happen. ADC, which we connect up to a potentiometer, could be a rotary encoder. A motor plus a rotary encoder put together, maybe with a PID algorithm, could become a servo. An interrupt pin plus SPI is an interesting way to create a UART, especially if your SPI can actually be 10 bits. That's another little interesting thing that I came up with a while back that I've always wanted to test out, never got a chance to. You can create an ADC with a certain number of input pins if you made a flash ADC bit of hardware, and so on and so forth. The last two that I want to just go over is the idea that you can take 2 output pins and 1 input pin and create an SPI. I want to have a bit-banged SPI so that for devices that don't have as many SPI peripherals or any at all, they could still get SPI control if they wanted to. And then finally, also input and output pin, take the 2 interfaces together, and you basically just run their you run their constructors in order to be able to switch between input and output control. And I want to have that available so people can use that. Now, your mileage may vary whenever you're using a soft driver. Some of these may perform just fine. Some of them will be slower, like the output pin, input pin to SPI, bit-banging an SPI. That's always going to be slower than using an SPI peripheral for a variety of reasons. It has to do with the number of bus cycles you have to do, but that's one thing. But we want to at least have these available so people can mix and match these things together. And that kind of shows the reason why we want this for the MVP is that it shows the modularity. It shows how you can compose and take other interfaces, combine them together in order to generate other interfaces in the event that you are strapped for I/O, strapped for whatever. Next up, we have our hard drivers. These are things that we'd expect, like you have a MPU6050 implement accelerometer and gyroscope, but I don't have gyroscope interface at the moment. An RMDX motor, which is the ones that we buy from AliExpress. These would both implement motor and servo. You have the DRV8870, which just needs PWM control output pin and potentially an ADC if you want to get current sensing, and that would be a basic motor controller. And then finally, we have the PCA9685. That would be the name of the driver, and it would return back 16 times PWMs because it has 16 channels, all run with the same frequency. And it would just simply need an I2C and possibly an optional output pin just for resetting the thing. Those are hard drivers, the things that we've been building for quite a while, honestly. I need to rename the title for this from I need to rename the title of this from pseudo drivers to stub drivers, like we have on the first line. But basically, stub drivers they implement an interface that basically do nothing. The functions that return something will return a single value always, and functions that return void will do nothing. These drivers are meant to be placeholders. So, for example, if you are using the ESP8266, which is a Wi-Fi module, you have your serial comms you're going to be using, and there's also a pin you can use for your output pin, and it can be used for reset. If you didn't really care about resetting it, or let's say you ran out of hardware or pins, so you actually can't, spare one for the ESP8266, well, what you could do in the code is put a placeholder in there that does nothing, one of our stubs. You can basically create one of our stubs and throw it in there. And whenever the ESP8266's constructor runs to actually set up the hardware, it will try to run the typical things it would do for output pin, but nothing would happen. And that's intended because you can also do reset via serial control. So the whole point of this is that if you deem something unnecessary or not needed, you can basically put in a placeholder. And I have one particular little bit of code snippet that kind of gives you an idea of what that's supposed to look like. So that's kind of the modular hardware abstraction layer. Now we go over to testability, basically mocks. So mocks of every single one of these things. Now these are not the same as the stubs. The stubs are do nothing functions for the most part, or the mocks. The mocks represent a way to do testing. So unlike all the rest of the code that we're writing here, the mocks, you have free reign to use whatever you like inside of C++, 20 or whatever, basically up to 20, at least for now. So that means if you want to use std vector and allocate a whole bunch of memory, or use std unordered map, or whatever you think is necessary for you to get this mock to work, you can go for it, because mocks are only meant to be run on unit tests. They can be run on device if you would be interested in doing that. You just got to take the hit of heap allocation and everything else like that. But the idea here is that each mock would allow you to simulate what a particular pin or peripheral or interface would do. For example, I2C. I don't actually think my next slide. Yes, mocks explained. So let's say we look at serial, command and response serial. The idea here is that you send a specific sequences of responses to command sent over serial. So let's say I send the numbers like hex AA and then like a couple other numbers after this. What can happen is that command and response serial is looking for the first thing to be AA and the next one to be another sequence of numbers. And when it gets a certain sequence, it will return those. It will return a certain response back. So this is a way to, if you have a lot of your devices work this way, where you send a message, it returns back a confirmation or returns back some data. This is a way that you could test out your ESP8266 module, because it'll always return back OK afterwards, and want to make sure your code responds appropriately when it sees OK, and that doesn't lock up or anything like that. Same thing with serial sender, something that just periodically sends some data over to the receive function, and you can grab it whenever you need to. I2C, simulated I2C device, acts as an I2C device with an n-bit address space, so maybe 8, 16, 24, 32, where sequences of responses can be mapped to specific registers. So you can use an unordered map and have a whole bunch of different registers with certain names, and like you can then modify those particular registers to do a particular thing and all that kind of stuff. And that way, you actually simulate the actual data within the memory map of an I2C device versus just simply having to kind of parse through certain responses and giving back those specific values. Same thing with SPI. SPI would be the same way, as long as it's also address-based device. ADC is another example where you could give it an entire sequence of return values you want it to return, and then you run your algorithm, and it will do the job of reading, collecting all that data, and then doing something like averaging it or coming up with a response or calculating it, that kind of thing. So that's the idea of mocks. And the idea is the mocks should make it really easy for the test developer to set up, rather than it being having to rewrite the same thing over and over and over again. So in a way, you should be able to simulate the majority of your code in unit tests and in integration tests versus having to, write your own simulations over and over again. We should have some code that helps you out with that. Next up, we have highly configurable and multi-platform. This basically goes over the idea that we should be multi-platform. We should be able to work anywhere. In order to make this happen, most projects would normally use macros, but there's this thing called a tweak file, which I really love and adore. This actually down here is not a tweak file. It's actually the config file that imports the tweak file. At the bottom, you can see if has include, that particular include, then include that include. The whole idea here is that, and sorry if I'm going over this again for those who've already heard this, namespace embed config internally has another thing called namespace defaults. And right below it, you see this using namespace defaults. When you have nested namespaces and then you use the using namespaces keyword, that actual namespace that's deeper, that you kind of tried to lift up, gets lower priority than things that are already in that namespace. Meaning that if I create somewhere else in my code, namespace embed config, and I put like context per string view platform, and I define it as something different, the compiler is supposed to take that one as the truth and ignore the previous one. No particular error should come up. Actually, no errors will come up for any compliant C++ compiler. This allows you to literally swap the definition of what platform is, get stack trace on error, all these other config options are. Our current things that we have are stack trace controls, what type of platform you're running. It defaults to test for unit tests, but you can also supply it with LPC 4078 or STM32F103 or whatever the platform you're currently running on. Additionally, I have an issue put on GitHub for SKU, which stands for stock keeping unit, which is basically just your serial number. And this can be configured to whatever you like. Some people have very distinct serial numbers they want to use for the project. Some people might just go standard BLE and Wi-Fi, like, oh, this is the version of our robot that doesn't have any wireless communication. Here's a version of it, or it needs to be wired, needs to be wired controlled. Another one could be BLE. This one talks over BLE over some app we have. The other one's Wi-Fi. You can control it from anywhere on the planet as long as it's connected to the internet. So, and you could write your code to be able to manage deciding which one of these it wants to choose depending on what build you used and what you set SKU to. You got basically, I would say you'd have a binary for each one of the SKUs, and also for every platform that you're trying to support as well. What does that sound? Weird. All right, so easy to install. This is it. Basically, it should be as easy as doing this in order to install libraries, and then including them should be as easy as just simply doing pound include chevrons, lib lpc whatever slash whatever, get your stuff. So Conan install lib stm32f103 or x and done. That's all you have to worry about. That is it. Another area that I want to bring up is clean, independent, and portable code. We've already talked about the style guides following the C++ standard way of writing libraries. Code should introduce the least amount of number of symbols in the global namespace to prevent name conflicts and linker errors. One particular thing that people will need to make sure that they do is that normally when it comes to embedded systems, we will have a header, like an H file, some type of header file that is both C++ and C usable. The problem with these is that because you're using C, and a lot of these files tend to not give really creative names for, I won't say really creative, that's not the right word for it, very verbose names. For example, you'll see can underscore type def underscore t. That's a okay name. The problem is if I also include a header for the LPC for whatever reason or anything else really, if something else defines can type def t, there's conflicts. There's literally a conflict between the LPC 40 and the STM32 header files. They will conflict with each other. Also, STM header files will conflict with each other as well. So this is a particular problem, and we need to make sure that we design our namespaces in a way that these things cannot conflict. Code should compile in any conforming C++ compiler. We shouldn't really be looking and trying to use parts of the compiler that are GCC specific. There are some aspects of our code that's mostly GCC and Clang specific, but we should try to limit that as much as possible, if not eliminate it completely. And not only that, but like our code shouldn't be set up in such a way that it could never really run outside of our air quotes ecosystem. There's no real ecosystem here, but basically you should be able to move this code around and it should just work as long as you get all the dependencies in. And the dependencies should be as simple as like header files in the right place. Oh, and this shouldn't depend on a specific compiler. And again, should just be clean, independent, portable code. Yeah. Last but not least, we have the safety critical areas. So I'm looking to try to have the code follow AutoSAR C++20. That's not out yet. They're still working on AutoSAR C++17. Currently we have C++14 available. I suspect that there's going to be aspects of 17 and 20 that like, there's going to be very little they're going to add for the features that come in for 17 and 20. Mostly just saying some blurbs about how to use 17 and 20 in a way that makes sense or isn't, bad. A lot of things that as an AutoSAR C++14, I think we're already following, and I'm already trying my best to make sure that we follow it as much as possible. Specifically, I think the areas regarding math and making sure we don't cause overflows are going to be the most important area in AutoSAR. But everything else, like not using exceptions, or actually exceptions are allowed, not using dynamic memory allocations, or at least allocating all at the start, and things like that. Those are all things that we're already doing. So we can probably be AutoSAR certified relatively easy. But the reason why we even want to do this is because we want to make sure that we open up the product to other clients, specifically automotive, military, medical, and government. I think if we can get people to, and even if we don't get too many people on that side, automotive or medical using our stuff, or even military, knowing that, hey, this is military grade, which actually doesn't mean anything, but automotive grade does mean something. So this is automotive grade. That means this actually will work pretty well in most cases, unless we make a mistake. But like the code is built in a way that will have a bunch of guarantees about how it should perform. So that's the reason why safety critical is actually pretty important to me, including in all the drivers that we build. So something to keep in mind. So that's pretty much everything that has to do with the MVP and what we need to do to get there. And I'm actually realizing that there are a couple things that I did not include. The mocks here are fine. I think, yes, I forgot to include issues for MPU 6050. And what else? I think that covers accelerometer. And I did not include the RMD for motor or servo, but I think I might want to include the DRV 8870 for motor. Maybe RMD for servo, which uses CAN. And potentially the PCA 9685 to demonstrate how you can take this driver for this chip and have each one of its separate components represent a separate implementation of the PWM interface to really show application developers, the flexibility of the code and how modular things can be. So these are probably 1, 2, 3, 4, 4 different repos, but also 4 different issues that need to kind of be built out. So the end number that I have at the end needs to be modified a little bit. So kind of going into revenue streams, if we actually were to make this thing profitable, I thought about this purely to make it more worthwhile for us to work on it, as well as to honestly put more of a commitment to making sure this thing actually happens in the future. Because I still look around at the world and what we have currently when it comes to our software for writing embedded systems, and it's still, I can't imagine removing libembeddedhal and then using anyone else's stuff. It just seems like nothing seems that satisfactory to me. So in this way, we're looking at ways that we can kind of generate revenue. One of those would be driver development contracts. My hope is that after a long period of time of us working at this and people starting to buy into this particular platform as the de facto standard that they use for embedded systems, I would hope that we get to a point where startups or companies will go, all right, we can use this set of chips, but this particular chip doesn't have a driver for it. So I guess we're not going to, we could use that chip. We have the right to drive ourselves, and we don't want to put in the time for that. Why don't we use something that already exists? And EE companies, electrical companies, will basically decide, well, if we want to be competitive out there, people need to have drivers where they can run our code immediately on their applications, on their systems, without having them having to download our entire IDE and use our particular hardware and our particular set of like little sensors here and there, because that's just going to disincentivize them to even try to use our stuff. So we can work up some deals with Maxim Integrated, Analog, Linear, these type of groups to write up software and drivers that basically allow us to communicate with the rest of libembeddedhal, and have them say, hey, all right, well, we want, or TI, let's say, hey, we have this one MCU, we want to have these 10 drivers implemented. We'll contract out for each one of these. This is the bounty we have for this driver, this driver, this driver, this driver, and this driver. And we can distribute those contracts and bounties amongst the people who are contributors. Another one is technical support and consulting. We could, if there are some startups that are interested in wanting to get our expertise and knowledge about how we should do software architecture using libembeddedhal, we can set up some individuals to give tech support on specific days or specific hours of the day to these startups, provided that there's no conflict of interest with any other jobs that you're doing. For example, I'm moving over to, if I'm working on like a consumer product and they're working on a consumer product that conflicts with my company, I will be sure to stay away from working with them, because yeah, that's conflict of interest. But anything else, like they're working on rockets or robots, or like just Mars rovers, I can help them out with that. That does not conflict with the work I'm doing. Next up, we have selling development boards. That's why I worked on the micromod. I kind of want to make one for the STM F103 as well. It's a cheap chip. People love it. People use it everywhere, and there's no micromod for it. And if you don't know what the micromods are, those are the new protocol that SparkFun came up with about a year ago, which I absolutely love and adore. I think it's a fantastic platform for developing chips and being able to swap them out. So I think our niche here would be, we need 2 boards to show off for MVP the capability of going, all right, well, we wrote one application for one board. Check it. I compiled the same thing, but I just changed the platform name, and now we have a binary for a different for like same code, just one line change, and now we have a binary for this other system. We compile that, and now we have something that works on the other system. And you'll see here that the binary did not, the binary changed in size relative to the drivers that were built for it, but they did not gain size. It's not like supporting both results in you wasting memory for each and every product that you want to support. I want to have that be around to support that. The YouTube channel, I actually started thinking about, and there's actually quite a few embedded YouTube channels out there that do a pretty good job. I think this one will be mostly focused on libembeddedhal news. So that'll be one area, libembeddedhal news, maybe like a little news talk about like, hey, here are the latest latest devices that are out there that we're planning to support. New contracts came from this one group, and we're going to be developing blah, blah, blah for them, unless they tell us to keep it under wraps, that kind of thing. But yeah, I want it to be a place where developers can go to get the latest and greatest on what's happening with libembeddedhal, as well as also get little tips and tricks. Like for example, I'm thinking about having YouTube shorts that go over really quick little snippets of things that you may not have known about the system. Like for example, my first YouTube short that came to my mind was, kind of goes like this. Checking the time, cool. It goes like this. Hey, have you noticed that your particular application is consuming more power than it normally does? Well, there's actually one thing you can do in order to reduce the power consumption. First off, if you're using FreeRTOS, create an idle task and put in a sleep function in there. The sleep function may vary depending on which platform you're using. Here's a way to add it in. Now, once you have that done, you want to go over to the delay function. There is actually an embed set global delay function. You want to replace that with a vtask sleep. That'll then allow you to sleep for that duration of time and either give another task the time to actually block your current task, give another task the time to do its thing, and when all those tasks are basically blocked or trying to sleep, the idle task will run, and you'll actually reduce power. So if you haven't done this already and you're noticing that your power consumption is way too high, this might be something you want to do, and that'd be the short. Things like that that'll pop up and kind of get people go, oh, I didn't think about doing that. Let's go into the code. Let's make sure we've done that already. So there's that. Another one is book sales. I've been actually meaning for the longest time to take my classroom documents and turn them into a book, but also to have this follow libembeddedhal. Before I was going to follow SJDev2, but I think that right now it makes way more sense, obviously, to do libembeddedhal. But I also want this thing to go over what I went over. A little bit of computer architecture, a little bit on startup code, go into what a GPIO is, what a I2C is, what an SPI is, what a temperature sensor is, these kind of things. I want to have blurbs in there that are like, quick things that people can just learn so they just get the concepts like that. But also if they want to go into the depths of this kind of stuff, into how to build drivers for it, how to design it well, use cases for when you want to use these things like that are more complicated or advanced than you normally expect, these kind of things. So developing a book would be really awesome. And, anyone who helps contribute to that would get some portion of the, I think it's loyalties that's called, basically the sales profits. And finally, donations. I'm hoping that we probably stay as a nonprofit for a variety of reasons. Makes working on this project as well while working at another company much easier a lot of different ways. And I also want a lot of this code to be open source and non-proprietary. So having this thing be pro-profit seems a little bit weird, but I'm still talking with my co-founder in this business that we're building up on this. So they'll be here probably tomorrow night. I won't be able to talk to them because they're busy up until like next week, but this is another thing that we're looking into. So that's our revenue streams. Now, if you're wondering how you get paid, currently in discussion, so we're trying to figure that part out. Contributors will probably get contracts under, contractors under the business, and contracts will be doled out at particular times. So wouldn't it be like you get paid salary or like hourly? It'd probably be like, complete this set of work and you get this particular payout from the other company that worked with us, or they give us the money. The money would then put into our business account. Money will be released to you once you've completed that particular task to their liking. So that's the pretty much that area. And then lastly, we have an MVP date August 24th. I think the next slide is, yeah. So currently we have a count of 64 issues, which I need to add probably another 5 to, maybe 6, so maybe 66, but let's say it was 64 now. To hit this deadline of August 24th, which is around about 4 months from now, or it's a little bit, it's actually not 4 months, but it's a little bit longer than that. We would need to crack down and have 3.2 issues done per week, which is actually quite a bit. But with enough of us working on this stuff in parallel, that might not actually be that hard to hit. But if that is too aggressive, I thought about, okay, well, what's a smaller amount of issues per week? Maybe just 2 issues per week. I think I could personally hit that up myself, actually. And that date would be November 16th. So right now I'm still figuring out what we should do when it comes to timing. One timing that I have to consider is I want to make sure to support the robotics team, make sure that they have this code available for themselves, but also just making sure we don't wait too long to the point where people have stopped caring about this thing. Although I don't think they'll ever stop caring. Just I want to make sure we get this out there sooner than later to get people to look at it, reflect on it, give us input, give us advice, or critique us, that kind of thing. And I'd rather not spend an inordinate amount of time getting this thing out there. I know one of the people that was in this group was talking about us doing a demo for a variety of places. I think we decided to cut that out now just to make sure that we have time to do this right and we're not rushing super hard. But I would like to go to a thing like Maker Faire and show off our code there and demonstrate what we can do at Maker Faire and have a whole bunch of us there doing the same thing. And yeah, and so that I'll probably look, me and the co-founder will probably be looking into, which will actually, the co-founder will be here in the next meeting, but I want to look into, areas where we can advertise. Other areas that are pretty easy to advertise would be Reddit, the CPP subreddit, CPP Lang, Slack, on TPP Cast. They actually asked me to come again just to talk over, say, hey, once you launch your thing, come talk to us. So I'll be able to advertise there. there might be a whole variety of other places like Twitter and places like that I can also advertise and see where that goes. I'm pretty connected with a lot of the people who are contributors to the C++ language, so hopefully they can help signal boost the project up there. So yeah, that's pretty much that. I'm going to open this up for any questions, and then questions that you're comfortable saying in this meeting, and then I'll cut this off, and then we can go talk about more things afterwards. So, any questions? Alrighty. If there's no questions, then I will cut off this particular thing.